This is going to be the entire lesson on this one, so it's going to be a little bit more of a lengthy video, but I wanted to cover quite a bit in this one, and I wanted to be able to put this one up online so you can kind of review it a little bit, because there's a lot to this lesson. So we're going to be covering piecewise functions, then domain and range. Okay, let's get started on this. We want to understand, first of all, what a piecewise function is. Then we can start evaluating them. What that kind of means is just basically plugging in a number. We'll get to that. We'll also graph those. And finally, we'll get to our domain and range of traditional functions as well as piecewise functions, both. All right, so this is what we call a piecewise function. And it kind of looks a little bit weird. We kind of have these little parenthesis bracket looking things here, and we've got a lot of information in between here. These look very, very difficult. These really aren't too bad, okay? We have a key that tells us how to use it. That's what we have over here on the right-hand side. Over on the left-hand side is what we're actually going to do our calculations through. So we'll kind of go through this. Well, the way that I'll ask this one is it'll say find f of -2. Okay, well f of -2, we have to kind of look over here. Again, the right-hand side is our key. So we're going to go through this and go, if x were -2, so see how we've got an x here? Now I replace that with a -2. So if x were -2, which one of these three here would it apply to? -2 is not greater than or equal to 4, so we would not use that one. It's not in between 0 and 4, we would not use that one. So we would use this one. -2 is less than 0. This would be the one that we would use. Okay, so if our x value is less than 0, we use this one right here, this x squared. So that's all we're really going to do. Now that we know that piece of information, we're going to take this and we're going to plug in -2 for x right here, and that's pretty much it. Okay, so that we've identified we're going to use this first one. Now I plug in -2 for x, and I square it. -2 squared is 4. So f of -2 equals 4. That's it. So while these look very, 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 very complex, it's really not bad. You just kind of look on the right-hand side, see which one of these we're going to use, then plug it into whichever one of those it is on the left-hand side. So let's bring in another one now. If I said find f of 7, again, we're going to go over here and look. 7 is not less than 0. It's not between 0 and 4. It is greater than or equal to 4. So it's going to be this last one here that we're going to use. So again, I'm going to write this one down. Now all I'm going to do, instead of writing x, I'm going to plug in 7. I'm plugging 7 in for x. Okay, so I plugged it in right here. Then I've got 4 minus 3 times 7 is 21. 4 minus 21 would yield us -17. So f of 7 is -17. Again, we figure out whatever one it is, 7 in this case. If x were to equal 7, it would be this last one. That's it. If we've said something like f of 2, 2 would be the middle one. That means we'd use just this one. We're not going to use all three of these at once. It wouldn't work. Okay, no number can be in all three of these. All right, so now we want to get a little bit of practice on this. What I'm going to do is, here are 3 problems. I want you to work all 3 of these problems. So push pause on the video now, go through and work all 3 of the problems. After you've obtained answers, come back and push play and we can check your answers. Check your answers here. The one that's a little bit tricky here is this one right here. It says -10. Well, there are 2 -10s here. If you'll notice on this one, it says x is less than or equal to -10. This one just says x has to be greater than -10. Well, -10 is not greater than -10, so that one would not work. So in this case, we would use the first one. So that's why I chose this first one. So it looks a little bit weird. If you ever get one of these numbers, only one of these is going to be or equal to, and then you'll use that one, okay? All right, let's get a little bit more practice on these. So here are 3 more that I want you to find. Push pause on the video now. Work out your solutions here. After you've obtained your answers, come back and push play. Check your answers here. Again, the same thing here, -5. -5 is in both of these 2. So you've got to find out which one it applies to. And this one is x is greater than or equal to -5. So we're going to use this second one. That's why I chose the second one to use. Okay, so here's kind of a real-life scenario. Dillard's is having a sale. Seems like they're always having a sale. If you spend $50, you get $10 off your purchase. If you spend $150, you receive $40 off your purchase. So what we're asked to do now is we're asked to create a piecewise function that explains this. And what I'm going to do here is I'm going to give you at least the right-hand side of it. Here's your right-hand side. If you spend less than $50, what's your equation going to be? We want you to use the variable x on this one. If you're between 50 and 150, what's your equation going to be? And then if you're over 150, what's it going to be? Push pause on the video now. I'd like to see if you can try to obtain the answer on this one. Then come back and push play. All right, let's talk about this one just for a second. X, you would not get any discount because you have to spend $50 to get the discount. So if you're less than 50, you don't get any discount. It's just whatever it is. If your price of your merchandise was $45, it costs you $45. There is no discount. But notice here, if you get $50 or greater than $50, it can be 50 or greater, then you get the $10 off. You get the $10 off all the way up until you spend 150. Okay, so there's our equation. Whatever your product amount is, your merchandise amount minus $10, that's your $10 discount. Okay, then if we go over 150 or equal to, can be equal to, then you get $40 off. So that's where my x minus 40 comes in. We're going to use this piecewise function right here on the next set of problems that we're going to do. So that's where these are coming from. Okay, these are coming directly from our Dillard's problem that we're working on right now. And that's where this piecewise function right here came from. Okay, now what I'd like you to do is work through these three. And then after you push pause on the video now, when you obtain your answer, come back and push play. Check your answers here. Okay, now the big thing here, now that you've done that, that's great if you could get all of these. But a more important piece is, what does it mean? What did these answers actually represent? Well, this means if your merchandise costs $45, you pay $45. Now, we're not including tax. It's another one. We'll get into those a little later. But it costs $45. If you spend $100, it doesn't cost you $100. You get a $10 discount. That's where our $10 discount comes in right here. So that would leave us with $90. It'd be our purchase price. So these are how much it costs if we were to buy $200 worth of merchandise. It would only cost us $160 in this scenario. So here's our scenario. Now what we're going to do is work on graphing these. Okay, so the very first one here, let's see, I've got an x plus 1. I bring in a graph here. This is y equals x plus 1. The graph of y equals x plus 1 will look like this. It'll go right through here at positive 1, and it's a positive slope, up 1 over 1, up 1 over 1. Okay, so this is what this one would look like. If I were to graph this one, just plain old 3, that would be y equals 3. That's a horizontal line right at 3. All right, and then finally I have an x squared. That one, x squared would look like this. So if I were to graph each one of these three individually, this is how all three of them would look. This is important because we're going to use a component of each one of these when we actually graph this one. All right, so let's bring these in. I just moved these off to the left-hand side. These are still the same graph, so I haven't changed those at all. Okay, so now here's the catch. This x plus 1, this graph right here, applies to everything that's less than -2. So that means it's going to change right here at -2. What I'm going to do is I'm going to draw a dotted line right here. This is technically not part of your graph. You will not include this as part of your answer, but it really helps to kind of see where we're going to break it up. Okay, and then between -2 and positive 1, looks like positive 1 is the next time it kind of breaks up again. So I'm going to draw another line right there, positive 1. And I dot the line and I color it blue just so I know that this is really not part of the graph. It's just going to help me graph it. It's really all. Okay, so it says if it's less than -2, it's going to be x plus 1. So I take my x plus 1 graph here, okay, and it would graph somewhere right along here, all the way down. But I only include the part that's less than -2. Okay, so we move this one in. There's my part that's less than -2. Okay, it doesn't apply to anything that's greater than -2 at all. Okay, so that's it. That's the only part of the graph that it would apply to. The next part is between -2 and positive 1. And that graph is just a horizontal line right here at 3. That means right here, 1, 2, 3. It's going to be right here. It's going to go straight across. But it doesn't apply to anything that's less than -2 or anything that's greater than 1. So it will only be right in between these blue dotted lines. There it is. Finally, I have x squared. And x squared kind of goes up like this, kind of comes down, and kind of goes back up like this. But I only want to focus on the part that's greater than 1. So I bring that one in now, part that's greater than 1. Okay, well this is kind of what the graph looks like. Now, here's where it comes a little bit tricky. -2 is not included. See how x is less than -2? So -2 is not included in this graph right here. The way we signify that whenever we graph is we put an open circle. So this one's going to be an open circle, meaning -2 here is not a part of this graph. But up here, -2, let's see, is less than or equal to x. Okay, so x here is greater than or equal to -2. So right here, we're not going to put an open circle because it's included. So now what we're going to do is put a closed circle. That means that -2 is included in this graph right here. And we look over here, x is less than or equal to 1. So that means this one's also going to be a closed circle. This one down here, it says x is greater than 1, so it's not included. That's going to be an open circle. There's our open circle. Now this is technically the graph. The only thing I'm going to do now is get rid of those blue lines. This here is your graph. This is what the graph of this one would look like. So if we go over here to -2 is not included in this graph, it's actually included in this one. Okay, and that's kind of all we're doing on this graph. This is the graphing portion of this. It's very in-depth, okay? We're going to give you a chance to practice these, but here's what I would do. It really helps me if I break down all three of them. Then I draw those blue lines and I go, okay, this part I'm only going to include whatever this one looks like less than -2. And I section each one of them off. It kind of helps me a little bit. All right, so let's have you practice these. Here are two of them. I want you to graph both of these. Push pause on the video now. After you've obtained the graphs on both of these, come back and push play to check your answers. Here are your answers on all three. Notice one other thing I failed to mention, but I need to mention this point, is arrows. Arrows indicate the graph continues. So this one does have an arrow because the graph continues on. In between here and here, right, this middle portion does not have any arrows because it does not continue on. It stops right there, and then the graph jumps down here and goes. Okay, so we want to make sure that we have these arrows. Also, I want you to verify that you've got open circles and closed circles in the correct locations. Those will be vitally important. I will be checking for those. Let's give you a little bit more practice on these. Go ahead and push pause on the video now. Graph both of these two. After you've obtained your answers, come back and push play. Check your answers here. Check to make sure that you included your arrows and that you have the open and closed circles in the correct location. Number 2 here was a little bit tricky only because I did a negative x squared, so make sure that yours looks like this. It should not be a positive, it should be a negative graph here. Okay. All right, now we're going to do another piecewise function. This is a real-life scenario here. And these are parking garages, and it says basically it charges you $3 every hour with a maximum of $10, okay? And you can only stay there 9 hours total, but a maximum of $10. So we want to create a piecewise function for this first, then we can graph it. Okay, so the first one is $3 for every hour. So between 0 and 1 hours, it's going to cost you $3. Between 0 and 1 hours, t is time in this case, 0 and 1 hours, it's going to cost you $3. If you're there right at an hour, it's only going to cost you $3. That's why I do my or equal to. Okay, if you're right at an hour, they're only going to charge you $3. If you're an hour and 1 minute, then it jumps up. Then it's $3 for every hour, so that would be $6 if you're over 1 hour, but less than or equal to 2 hours. Okay, if you're 1.1 hours, or if you're 2 hours, they're going to charge you $6. And then if you're there 3 hours, they're going to charge you $9. And then if you're greater than 3 hours, they're going to charge you $10. Now, with the notion that it's capped out at 9, maybe they're only open for 9 hours and that's it during the day. So now what we're going to do is we're going to graph this. We've got the cost in dollars and then the time in hours. Okay, so for there between 0 and 1 hours here, it's going to cost me $3. It's going to go right here. Okay. Now, the reason why I have an open circle right here, if you're there for 0 minutes, they're not going to charge you anything. You're not there at all, okay? But as soon as you're there for 1 minute, boy, they're going to charge you that $3. Okay, so I want you to look at this graph here, and I want you to kind of surmise and at least guess where the next one's going to look like, okay? And this is a closed circle because at 1 hour, it's only going to cost you $3. Okay, the next one says 2 hours, between 1 and 2 hours. What's that going to look like? And that should look like an open circle here and a closed circle here. Remember, if you're there for right at 1 hour, it's going to be $3. It's going to be down here. Then as soon as that 1 hour is up, it jumps up here to $6. It doesn't cost you $5. There is no graduating one. It costs $3 per hour. Okay. Then for the 2 to 3 hours, it should cost you $9. That should look pretty similar. Then we have 10 hours. Excuse me, 10 hours. $10 for anything larger than 3 hours, all the way up to 9 hours. Okay, and it just should look just perfect, just like that. All right, now I'm going to give you one. I'm going to have you work on it as well. This is another real-life scenario. Okay, this is a rental car company. I want you to come up with the piecewise function first. After you do that, come back and let's do the graph on it afterward. So see if you can do both of those. Push pause now. After you've obtained those two, come back and push play. Check your answers here. Okay. Now this one I do have a closed circle on it. That's if you did 0 miles. They're going to charge you 0. That's okay. I'm not going to charge you anything. If you did an open circle there, don't worry about it. That's okay too. I'll take either one of those in this case because it's not going to cost you anything. So either way you want to do that is fine with me. But this one should definitely be a closed circle here. Okay. If you have a question on that, you want to just take a second and read through it. Okay, if you drive 4,000 miles, it's going to cost you $400. Okay, from there on out, it's just a flat rate of $400. Nordstrom's is having a sale this time. We had Dillard's last time. This time it's Nordstrom, and you're going to receive a percentage discount. So I want you to develop this piecewise function based on percentages. Okay, not dollar amounts, but percentages. Your dollar amount is going to have to be your inequality, like x is less than or equal to, those kind of things. That's going to be your dollar amount. The other one is going to be a percentage. So I want you to see if you can come up with both of those. Push pause now. After you've obtained those, come back and push play. Check your answers here. Okay, and this is 0.1 discount. We're just trying to graph the amount of discount. Okay, so you're going to be a 10% discount off of the total price. This one would be a 20% discount, and this one would be a 30% discount. And notice how this one continues on. Because if you were to spend, let's say, $900 at Nordstrom's, sounds like a lot of money, but Nordstrom's is a very expensive place. $900 is not unrealistic. So $900, you could still easily spend that. You'd still get your 30% off. And sometimes you do that whenever you're trying to replace an entire wardrobe or something. Maybe if you got a new job or something along those lines. Okay, now we want to graph these three. So go ahead and graph these two. Graph these two. After you've obtained your graphs, come back and push play. There are your three graphs. Now we're going to move on to what we call interval notation. We're going to talk about domain and range. Remember that the domain is all of the possible x values. We went over that in class yesterday. The range are all of your possible y values. Okay, and here's our symbols that we're going to use. This is going to be important. What I would do is I would copy these down in my notes. Okay, I'm not going to spend a long time just waiting for you to copy it down. Just push pause on the video and copy it all down. That'll be the easiest way. But all of these are very important. Open parentheses, close parentheses, brackets, if you will, infinity sign, and the union sign. We're going to use all of these. Let's bring these in. If we were to graph this one, your graph on this one would look something like this. Okay, it intersects right here at -1, and your slope is +2, up 2 over 1. Okay, now remember your domain are all your x values, so any possible x value that we have here. And the way I determine that is I kind of start. Now, because I'm doing it on a computer, you can't see my pen, but usually what I do is I just drag my pen straight across, and I look to see where it intersects. And while it doesn't look like it intersects right here, notice how we have an arrow. That arrow means this is going to continue on and on and on. Eventually it will hit this blue line here. Then I just drag this blue line all the way across. Notice how it intersects everywhere, even over here, because remember this is going to go on, it'll keep going like this, it'll intersect somewhere around here, okay? It intersects everywhere. So the domain on this one are all of them, okay? There's nothing that's not included. So for that one we say -infinity to +infinity. And anytime you use infinity, you're going to use the open parentheses, this curved parenthesis right here. You're not going to use the bracket, okay? So -infinity to +infinity. Now let's bring in our range. Range are all of our possible y values. I'm going to do the same thing. I bring in this line and I start dragging it up. This one would be included because remember it keeps going down. So, and I just drag this across. Notice how it intersects everywhere along here. There is a possible y value. Okay, I mean it intersects at +1, +3, -4 over here it intersects. So the range is also -infinity to +infinity. So this is your domain on this particular one. This is your range on this one. I want you to take a second now, and I want you to write down the domain and range on both of these. And you just listed domain is this, range is this. I'll give you a hint. One of these does not have -infinity to +infinity on everything. So pay attention to that. All right, push pause on your video now. After you've obtained your domain and range, come back and push play. Check your answers. Okay, the second one was clearly the one that did not have -infinity to +infinity for both of them. Because if we look at the range, remember is your y values. If we look at this, there is no -4 here? There is no -4. There's no -3, no -2.5. Okay, it starts right here at 0. 0 is included in this one. If x equals 0, 0 squared would be 0 for your y value. So 0 is included. So if it is included, we do use closed parentheses, this bracket. And that sounds weird because infinity, we always use the open one. Infinity is more of a number that we can never reach. It's more of a concept. Okay, we can never reach infinity. So that's why we always just use the open parenthesis. But anytime that number is included, we're going to use this closed bracket with the exception of infinity. Okay. All right, so let's get some more practice on this. Push pause on the video now. After you've obtained the domain and range on both of these, come back and push play. Check your domain and range on this. I think I said range previously. Sorry, it's range. This one here is an important one. The only y value that this one ever hits is -3. It doesn't hit -2. It doesn't hit, +5, +1. None of those. Just -3 is the only one, and it is included. So we do use our closed parenthesis. Over here, y values, it includes all of these because we have these zeros, all the way up until +4, and +4 is included in that one. The way we know that it is included, we can always just plug in the x value. The x value for this one is 0. 0 squared, it means your y value would be 4. Y is included in that one. So 4 is included, so that's why we use a closed bracket here. Okay, now I want you to go ahead and do this. When you type this one in your calculator, you may have to type this in, especially with your TI Inspire. ABS, that's for absolute value, and then you use parentheses. Just type it in just like that, and it'll show this graph if you want to. Or you can just look at this one and know, and that's fine too. All right, so push pause on the video now. After you've obtained your answers, come back and push play. Check your answers here. Okay, this one again was -infinity to +infinity on both. We've kind of hit that one pretty good now. Hopefully you'll get all of those right. On this absolute value one, if we look down here, let's see, all my x values would be included, negative to +infinity. And your y values, let's see, it goes down here, hits 0, then bounces right back up. So 0 would be included. That's why we're going to use a closed bracket. But there is nothing lower than 0 for your y values here. There's no -1, -2. None of those are included. So just right at 0 would suffice. Okay, now let's talk about the domain and the range on this one. And this one you can still do where you drag your pencil across, or your pen across, and see where it intersects. That might be the easiest way. I'm just going to do one just a little bit different, just in case that one didn't make sense to you. We'll do a completely different way of finding the domain on this one. But realize that that pen would still work. You would drag it across here. You would realize that it would hit right here at -2. -2 here is not included, but up here it is, so that would still work, and it would continue on. But I'm going to do it just a little bit different way here. And the way that I'm going to do is I'm going to focus right here on this right-hand side. Domain x is less than -2. Okay, so if we focus on that one here, if I were to graph that one on like a traditional number line, here we go, I've got a -2 here. I'd have an open circle and it would go this way, and it would include all of these numbers that way. Okay, now if I go from -2 to +1, okay, and it looks like it's a closed circle here and a closed circle there. It would look something like this, okay? I just did it above so you can see where that one's coming from. Okay, now I can drag that one down. Okay, so it includes all of this, including -2, keeps going. And right here, this is a greater than 1. Okay, so if it's greater than 1, it just goes in this direction. So if you look, the domain actually includes everything here. So that's going to be -infinity to +infinity. And if we just took a straight line here and drug it across, if we drug it right here, it would not include -2 here, but it does up here, so that's okay. So then we keep going over here, and it does include +1 here, but not here. So as long as it includes it somewhere, we're good. And we keep going this direction, and it would be -infinity to +infinity. Okay, so now let's work on our range here. Remember that range are all of our y values. So I will do the line here to drag it up. So I drag it all the way up, and it includes everything there all the way up until -1. It does not include -1. So I go -infinity to -1. Notice how I use an open parenthesis here, okay, the curved one, because this is not included in this data set here. Okay, now we're going to use our unions. First time we've done that, because it does continue here. So we're going to use our union, and as we drag this all the way up here, it includes everything there, but it does not include +1. So that's where we use our union right here. It includes +1 all the way up until infinity. Okay, so the only things that aren't included are everything between -1 and +1. None of these are included in our y values. This would be our domain, this would be our range for this one. Okay, I'm going to have you try this. Now, I gave you the graph on this one because the next one I'm not. I'm just going to give you the piecewise function here, and you're going to have to graph it yourself, then come up with the domain and the range. But this one, I want you to see this graph, then I want you to just focus on the domain and the range for a moment, okay? You can use your pen if you want, you can use whatever method you want to on that one. Push pause on the video now, though. Spend some time, see if you can get obtain the correct answer on that one, then come back and push play. Check your answers here. Okay, so let's talk about this one. Domain's kind of easy. It includes everything there. The range on this one, though, everything is included here. all the way up until we hit 2. Actually, it all was covered in this one here. We didn't even need this one nor this one. We'd come up with the same answer, but that's okay. They're still there. It doesn't hurt us. Let's move over here to this one. Okay, this one said -4, so our y value did include -4, so that's why we use our closed brackets on -4. This means it includes -4 and everything over here. And so this is -2. -2 is not included, that's why we use an open parenthesis. And then everything greater than -2, basically, all the way to infinity. So that one was not a problem at all there. Now on the next one, you're going to have to graph these and come up with the domain and the range. These are very challenging. I know you can do it. You got to go slow a little bit. So if you want to pause it right now and write down some notes or something, that would be fine too. Okay, so we've got these here. I want you to go ahead and I want you to attempt these. Push pause on the video now. First graph them. I find that's going to be 1,000 times easier. Graph them first, then you can identify your domain and range. So push pause on the video now, then come back and push play after you've obtained your answers. Here's your graph on this. Make sure your graph is correct. If your graph isn't correct, go ahead and push pause now. Adjust it to make sure that it matches. Then you can do the domain and range. Here's your domain and range on these. A little bit more challenging now. If you notice on this one, 2 is not included, either one of these two. So we leave an open parenthesis here plus open parenthesis here. Basically everything's included except 2. Okay. This one here, both of these, -2 was not included here and +1 was not included here, so that's why we had open parentheses there.